The James Webb Space Telescope, JWST, has revolutionized our ability to study distant planets, particularly those that are similar to Earth. For many years, the dream of discovering a planet teeming with life, rich in vegetation and water, like our own home, has captured the imaginations of scientists and the public alike. Now, with the groundbreaking capabilities of the JWST, that dream is becoming more of a reality. Among the many discoveries that the JWST has made, one of the most intriguing is the study of a planet called 55 Cancri e, an exoplanet located just 41 light-years away from Earth. This exoplanet, often referred to as a super-Earth, has perplexed researchers and provided new insights into the possibilities of life beyond our solar system. At first glance, 55 Cancri e seemed to be an uninhabitable world, characterized by extreme heat and likely to lack any significant atmosphere. For years, scientists had believed this planet was a molten, rocky world, too close to its parent star to maintain any conditions that would allow life to thrive. The planet orbits its star, 55 Cancri, at an incredibly close distance, leading to surface temperatures that can exceed 2,400 degrees Celsius. This extreme heat would seem to rule out the possibility of life. However, thanks to the James Webb Space Telescope, scientists have been able to take a closer look at this planet in a way that was previously unimaginable, revealing secrets about 55 Cancri e that challenge everything we thought we knew about planets like it. The story of 55 Cancri e's discovery and the ongoing research into its nature is a fascinating one, full of unexpected twists and revelations. Since its initial discovery in 2011, 55 Cancri e has been an object of great interest and puzzlement for astronomers. It was first identified as a rocky, superheated planet that might possess an atmosphere, but there was little concrete data to confirm that theory. As the years passed, additional studies of the planet were conducted using various space telescopes, but the data was inconsistent and contradictory, leaving scientists frustrated. Some instruments, such as the Spitzer Space Telescope, suggested that the planet had a molten surface with little to no atmosphere, while others hinted at the presence of an atmosphere, possibly one that could support life. Then, the arrival of the James Webb Space Telescope changed everything. Webb is equipped with cutting-edge spectrometers capable of detecting the chemical makeup of a planet's atmosphere, including gases such as carbon dioxide, methane, and water vapor. The JWST's advanced instruments have allowed astronomers to peer deeper into the atmospheres of distant planets than ever before, uncovering details about their composition, temperature, and potential for habitability. When researchers turned Webb's instruments to 55 Cancri e, they were able to gather data that shed new light on the planet's atmosphere, revealing that it is much more complex and dynamic than anyone had imagined. One of the most startling findings was that 55 Cancri e appears to have two separate atmospheres. The first atmosphere, made primarily of hydrogen and helium, was likely stripped away by the planet's close proximity to its star, which bombards the planet with intense radiation. However, the planet did not remain bereft of an atmosphere for long. In an astonishing twist, 55 Cancri e appears to have regenerated a new atmosphere, this time made up largely of carbon dioxide and carbon monoxide. This outgassing from the planet's rocky interior has led scientists to believe that the planet underwent a dramatic transformation, with its surface heating to extreme temperatures that allowed gases to escape from deep within the planet and form a new layer of atmosphere. The fact that a planet could lose one atmosphere and then regenerate another is an unprecedented discovery, and it challenges our understanding of planetary evolution. The creation of this new atmosphere is not just a fascinating scientific curiosity, it also provides important clues about the planet's past and the conditions that might have existed there. For example, it raises the possibility that 55 Cancri e could have once been a cooler, more habitable planet before being moved into its current orbit, which brings it perilously close to its star. Just as our own Mercury is slowly being pushed closer to the Sun by gravitational interactions with Jupiter, it's possible that 55 Cancri e was once located further from its star, in a region where liquid water might have existed on its surface. If this is the case, it's possible that the planet could have once harbored conditions conducive to life. However, even with the revelation of this new atmosphere, scientists are still grappling with questions about 55 Cancri E's potential for life. The temperatures on the planet's surface are so high that it seems unlikely to support life as we know it. The day side of the planet reaches temperatures of around 1,540 degrees Celsius, which is still extremely hot but lower than previous estimates. This reduction in temperature could be due to the planet's ability to distribute heat from its scorching day side to its cooler night side, thanks to the nature of its volatile atmosphere. This phenomenon, called thermal redistribution, means that the heat on 55 Cancri E is not confined to just one side of the planet but is spread out more evenly, which could explain the lower temperature readings observed by Webb. This is a surprising result, as it was initially expected that the planet's extreme heat would create a more uniform temperature across its surface. To understand how such a planet could maintain a relatively cooler temperature, researchers looked deeper into the data from Webb's MIRI, mid-infrared instrument, and NIRCam, near-infrared camera, instruments. These instruments revealed that the planet's atmosphere is rich in volatile compounds, which suggests that the planet is not just a lifeless rock but a world with an active and dynamic atmosphere. The presence of such gases is intriguing because it indicates that the planet's interior is still geologically active, with processes like volcanism possibly taking place beneath the surface. This is important because it suggests that the planet's environment might be constantly changing, and this could have implications for its ability to support life, or at least for our understanding of what kinds of conditions might exist on planets in the same category. The implications of this research extend beyond just 55 Cancri E itself. The study of exoplanets like 55 Cancri E helps scientists learn more about the vast diversity of planets that exist throughout the universe. Although we know of more than 5,000 exoplanets so far, this number is still a tiny fraction of the total number of planets in our galaxy alone. Many of these exoplanets are gas giants, while others are rocky worlds like Earth, and some, like 55 Cancri E, are in a category of their own. The more we learn about these distant worlds, the better we can understand the range of conditions that might support life, or the potential for life to have existed in the past. In many ways, 55 Cancri E represents both the promise and the challenge of exoplanet research. It's a planet that could have once been habitable, but now exists in a state of extreme conditions that make it unlikely to support life as we know it. As scientists continue to analyze the data from the JWST, they are uncovering even more surprising results. One of the most fascinating aspects of 55 Cancri E is the possibility that its atmosphere might have once contained elements that could be considered biomarkers, substances that are typically associated with life. Previous studies using the now-retired Spitzer Space Telescope hinted at the presence of oxygen, nitrogen, and carbon dioxide in the atmosphere of 55 Cancri E. While these gases are certainly important for life as we understand it, they could also be the result of non-biological processes, such as volcanic activity. The discovery of these gases in the atmosphere of 55 Cancri E has reignited the debate over whether there could have been life on this planet in the distant past, and whether it is still possible for life to exist there under the right conditions. These discoveries have profound implications for the search for extraterrestrial life. If we are to find life on other planets, it is likely to be very different from life on Earth. Life on exoplanets might not look anything like the plants and animals we're familiar with, and it may not even be based on the same biochemical processes that we rely on. However, the study of exoplanets like 55 Cancri E is helping us to expand our understanding of the conditions that might support life, and it's opening up new possibilities for what life in the universe might look like. While 55 Cancri E remains an unlikely candidate for the existence of life today, the fact that we are able to study its atmosphere in such detail is a testament to the capabilities of the James Webb Space Telescope. With its unprecedented ability to analyze the atmospheres of distant planets, the JWST is opening up a new chapter in the search for life beyond our solar system. While we have not yet found definitive proof of extraterrestrial life, the discoveries made by the JWST have brought us closer than ever to understanding what makes a planet habitable, and whether life could exist in places far beyond Earth. The search for Earth-like planets is far from over, and as the JWST continues to study exoplanets across the galaxy, we are likely to uncover even more incredible discoveries. Planets like 55 Cancri E might not be the perfect candidates for life, but they represent the many mysteries and possibilities that await us in the vast expanse of space. As we continue to push the boundaries of our understanding, the dream of discovering a truly Earth-like world remains within our reach, and the possibilities for the future are limitless. With each new discovery, we come one step closer to answering the age-old question, are we alone in the universe? The journey of exploration has only just begun.